Okay, so this is the Year 8 Electricity and Magnetism knowledge test. It's all the answers to get to get maximum marks on the test. Right, so name and draw the 14 electrical components. Alright, so what I'm going to do is I'll just draw them first. Okay, it's probably easier. Right, no, I won't draw them first. I'll give the names. So that then is an open switch. Can't fit it in. That's a switch, by the way. That is a closed switch. Gosh, my writing's terrible on here. That is a lamp. And then a box like that with a line going all the way through is a fuse. Change colour. A line, long line, short line, line out is a cell. A circle with a V in it, with a line there and a line there, is a voltmeter. An A with a circle and a line out line there. I like putting the line out there because it kind of makes it look more like an electrical component. Is an ammeter. And then line, dot, line is a battery. Okay, let's go for purple. Now some of these are getting a little bit more complicated to draw. So it's a triangle with a line at the end, a circle that goes all the way around it, and then a line that goes right the way through the middle of the triangle, and that is a diode, D-I-O-D-E, diode. A rectangle with a line there and a line there is a resistor. Okay, just look at the difference then between the resistor and the fuse. The fuse has got a line that goes right the way through the middle. Box, and then a hockey stick. Right, now I know it's a resistor of some sort because it's the same shape as a resistor, and because it's got a hockey stick or that line there, what it then is, it is a thermistor. Right, so a thermistor is all to do with temperature, and I think of it as an ice hockey stick because it just kind of looks like an ice hockey stick. Then that makes you think of temperature. Here's another one, is a line, a box rather, that there, and then an arrow going through it. That is, I'm never going to fit this in, is a variable resistor. Okay, let's go for a different colour. We've got two more to do. I'm going to write down or do a rectangle. I'm going to do a line coming out, and I'm going to do a circle around the outside and two little arrows there. It's a resistor, right? But it is an LDR, which is a light dependent resistor, LDR. The final one, right, because we've got two extra boxes here that we don't need, right, is a triangle, line all the way through, circle, arrow. That is an LED, right? Probably some of the stuff that's going around the top of your bedroom, all right, is a light emitting diode, okay, an LED. Question number 2, draw a series circuit containing two bulbs and an ammeter. Right, now obviously you've got to draw a ruler with this. Now it's a little bit harder for me, right? So there's my cell. Doesn't say draw a cell, but you always have to draw a cell. Two bulbs and an ammeter. So what I'm going to do is I'm going to draw an ammeter, I'm going to draw a bulb, I'm going to draw a bulb. Now with a series circuit, series means there's only one route for electricity to go. So I'm going to go along there, I'm going to go down, I'm going to go into that, into there, there, and across. Okay, so that's a series circuit because there's only one route for electricity to travel, and they're all in the line. Draw a parallel circuit containing two bulbs and an ammeter. So I'll draw my cell, right? I'm just going to draw an ammeter in the same place that I did last time. Now because I know it is going to be a parallel circuit, I'm going to draw them above each other like that. Okay, this time it comes out, it goes down, and it goes into that one, comes out of that one, there. Now that is a series circuit with an ammeter and a bulb in it. However, to turn it into a parallel circuit, what we have is that. So now electricity has got one route it can take, and it's also got a second route it can take, and that is then a parallel circuit. Number 4, define current. Current is the rate of flow of electricity. So potential difference, when I was at school it was always called voltage, okay, but now it's called potential difference. It is the measure of, there's an R in measure by the way, of energy transfer between 2 points. Resistance. Okay, so resistance is the opposition to energy transfer, or it can be the opposition to the flow of charge. Question number 7. Describe and explain the brightness of bulbs that you drew in question 2 and 3. So in question number 2, the bulbs are dimmer as the voltage is shared. And in question number 3, the bulbs are the same as the voltage is the same. Draw the magnetic field around a bar magnet. Where is the magnetic field the strongest? Okay, so what happens is from this it goes from north to south, it goes from north to south, it goes from north to south, oops, it goes from north to south, and what you do is you draw little arrows on it. Okay, showing the direction. And it is strongest at the poles. So that's arrow going away, going away, going away, going in, going in, going in. So draw the magnetic field around the bar magnet. Where is the magnetic field the strongest? Okay, it is the strongest at the poles. And it is at its weakest away from the poles. Explain how the electromagnetic works to make a bell ring. Alright, now what you've got to do here is you've got to really study the diagram. Okay, so what you've got here is that red line there, right, is the electric wire. Right, and when electricity passes through that wire there, what it does, it turns it into an electromagnet. Then what happens is, if I just call it orange, what's the best colour? Blue. When it becomes an electromagnet, what it does, it attracts this kind of armature here, which is iron. When that gets attracted to that, what happens then is this little break here, there, if you can see that, opens. And when that opens, current stops. And when the current stops, the electromagnet turns up, and then that then goes back again. And so when that's actually pulled, it dings the bell. Okay, so if I then write that down, right, it says current flows making an electromagnet. Okay, so that's when the current actually flows through that red wire. That electromagnet then attracts the iron armature, which is this thing here, and rings the bell. Then, when the actual armature moves, which is this moving here, then what happens is the circuit breaks, so there is no current, so it all starts again. Now for that one, what I'll do is I'll just study the diagram. right? You can go on YouTube and you can find other YouTube videos that show it actually happening, right? But it's quite an important one. If you can understand that, then that's fantastic. Keywords. Unit of measurement of electric current is amps, amperes. Conductor, a material that conducts a charge or energy well, such as a metal or graphite. Conductor. A metal that does not conduct electricity is an insulator. Unit of resistance, symbol, funny little hat-shaped horseshoe standing on its head, is an ohm. The unit of potential difference is a volt. Right, now this topic is a lot about understanding. Okay, so what you need to do is you need to learn the definitions, you need to understand exactly what's happening with the electricity and think about it as electrons that are flowing. Right, so it's electrons that are actually moving in a circuit. Do the test yourself, okay, using the other video that then is also up on YouTube.